I'm Jessica Benner.
Hi, I'm Jonathan Warner.
And I'm Allison Lacani. Urine was rinsed 3 times with sodium hydroxide solution before use.
Go.
I started off with 25 milliliters of citric acid in my flask. And we start off with 50 milliliters of sodium hydroxide solution. Ready? By turning this, we add sodium hydroxide solution to my citric acid. And we wait for color change.
There we go. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right. Go.
We're left with 7.50 milliliters in our uree. So when we subtract it, we get 42.50 milliliters of sodium hydroxide in our solution.
Okay, we rinsed our urine 3 times with sodium hydroxide to make sure that there was no other solution in our urine. First, we read our initial volume. And here, we've started off with 50 in our uree. And then we slowly start to release into our solution, which is citric acid. And we wait for color change.
We need these points more than anything.
1, 2, 3, 4, 5, 6, 7, 8, 13, 14, 15, 16, 17, 18, 19, 20. Alright. Now, we take our final volume, which in this case is at 32.12, and then we subtract what we have left in our burette from our initial volume, so our final minus our initial, and we get our transfer, which ended up in our solution.
Alright, it's important before starting to make sure that we rinse our burette 3 times with NaOH solution. Okay, to begin, we have 50 milliliters of NaOH solution in this burette, and we're going to titrate 15 milliliters of the citric acid solution. So, to start, we're just going to start adding the solution slowly and mixing it in. I'm going to see if I can get it to hold its color now. Now there we go.
20 seconds.
Now it has to hold its color for 20 seconds before we can determine that that's been titrated.
20 seconds.
Okay. Now it's not supposed to be this dark, but from this we can read our final volume is, let's see, 24.2, 24.4. So that means we'll have 50 minus 24.4, 24.4 for, let's see, how close is that? I'm going to say that's 0.40, and that gives us 25.60 stilling.
Go. Titrations are performed in this case to determine the concentration of a certain analyte in the solution. Before we begin, we have already found the molarity of the sodium hydroxide, and we know how much citric acid we have in our Erlenmeyer flask. To read the volume, get at eye level with the top of the solution and read from the bottom of the meniscus. to 2 decimal places.
To find out how much NaOH it'll take to completely react with the citric acid, we titrate NaOH into the citric acid and wait for the indicator previously added to the citric acid to turn pink. We then take the final volume that's in the burette and subtract it from the initial volume to get the transfer volume.
So let me show you my calculations. So we start out by finding with our experiment how many milliliters of NaOH it takes to titrate our solution. Using this, we can figure out how many moles of NaOH that it takes and use the stoichiometry to figure out how many moles of citric acid we have in our volume. We use this to calculate how many moles or the molarity of the citric acid, and use each of these three to determine that we have 0.0065 molarity citric acid.